Hi, I'm Andy Jackson from the Daytime Monks team. I worked with Tom and Michael to create the Manchester Codes community quiz app. We set out to create an app that past, present, and future students can use to practice and strengthen their knowledge of the Manchester Codes syllabus through a selection of interactive games and quizzes. The bootcamp is a part-time course that stretches over nearly 6 months, so we wanted a central space where knowledge gained along the course could be consolidated. We also hope it can act as a hub for some learning activities. To apply agile methodologies, we used GitHub's project board and integrated draw.io into our repository so that any diagrams would be part of the project's commit history. We planned out how the app might work using wireframes, ERDs, and worked together to define MVP user stories. Most of our development process was based on mob programming sessions. These sessions began with a brief stand-up of issues that we had discussed in the Slack channel and how we might solve them. Throughout the development process, we regularly reviewed what features were working well and what features could be improved. For our front end, we chose to use Next.js as we wanted to use our JavaScript and React skills with the added challenge of using a new framework. We were keen to use Next as it offers additional benefits to React, including built-in routing using logic and the file structure to define routes, an API routing system allowing us to create an API within the Next project, eliminating the need to have a separate API solution, built-in and pre-configured linting, search engine optimization benefits, server-side rendering of static HTML pages using React, which allows the pages to be pre-rendered, reducing the need to fetch data client-side, giving the app a performance boost. The concepts of server-side rendering proved challenging at first, particularly as we come into it fresh from React's client-side rendering. We tackled this challenge by making use of the browser's local storage API. We use this to store the state of our application. Data stored in local storage persists between page refreshes, navigation between pages, and even between user machine power cycles. This allowed us to store question session data, which gives users the option to complete a previously incompleted question round if there was an interruption. Using local storage also provided us with a temporary solution to persisting user data, allowing us to experiment and develop the features of our MVP without having a fully developed backend structure. For our backend, we used MongoDB and Prisma. We used Prisma as our object relational mapper because it supports several popular databases and has a command line interface tool that makes common database management tasks much easier. Prisma's query syntax is built on top of JavaScript, eliminating the need to write SQL queries. We use MongoDB for our database because data is stored in BSON format, which is very similar to JSON and JavaScript object syntax. This allowed us to start off the development process using a dummy dataset in JSON format that later on could easily be imported into our MongoDB database. The similarities of BSON, JSON, and JavaScript objects made it easier to manage data as it moved through the flow of our application. In general, MongoDB is more flexible than traditional relational databases, and we felt that this would be helpful should the application develop further. Tom's going to talk about the challenges we faced in building our app.
Hi, my name's Tom Mills from the Daytime Monks. What problems and challenges did we encounter? The main challenges we faced were the implications of using technologies that were both unfamiliar to us and relatively new, such as Next and Prisma. There is less guidance available and some features are still being finalized for these packages. Next.js relies on server-side rendering in contrast to React, which is rendered client-side. Using local storage was particularly challenging as we could not access it until a page had fully rendered. It made features such as not losing progress on the quiz difficult to implement. As we were using Next.js, we chose to use the NextAuth package to handle user login. We wanted to allow at least 2 login methods, one with GitHub and one to log in as a guest. Unfortunately, we had issues with setting this up in production but did get it working while in development. This is something we plan to address in the future. We chose to use Prisma to query a MongoDB database. The ability to automatically generate schemas from the source database was useful. However, as Prisma was an unfamiliar technology, it was initially a challenge to understand and set up correctly. We approached developing our basic wireframes of our app with React in mind. When we began writing code in Next, these wireframes worked differently to how we had planned. If we had considered the implications of Next, our early design decisions would have been more cohesive. This shows in the CSS. With more planning with Next in mind, we would have led to more concrete design and then clearer CSS.
Hey everyone, I'm Michael Shields from the Daytime Monks team, and today I'll be demoing the app and showing you some key areas of the codebase. The Manchester Codes tutors named our project the Manchester Codes Community App, so we decided to take inspiration from the styles and branding of the official Manchester Codes website. When the user loads the homepage, if they are not signed in, there is no current valid user session, so an invitation to sign in is displayed. So let's go ahead and sign in. Once the user has clicked the sign in button, they are redirected to a next auth page where they can sign in with their GitHub account or as a guest user. I'm going to choose to sign in with GitHub, which redirects the browser to a GitHub authorization page where the application can be authorized with a GitHub user account. On successful sign-in, the browser is redirected back to the home page. Now that there is a valid user session, the game options component is rendered. Rather than hard-coding the question options, game options queries the questions database for an array of unique categories. So let's go and take a look at the code that implements that functionality. To determine the list of unique categories, we make a query for all of the questions in the database and then apply the reduce method to the array of questions that is returned from this query. The reduce method collects all the unique categories that it finds in the questions data and returns this to the client where they are rendered as options for the user to select. Below the categories options, there is a number input to select the number of questions in each round. If you observe the Local Storage tab in the DevTools on the right-hand side, you will see that any changes to the user inputs are stored in local storage. When the user clicks Play Game, they are redirected to the game page. When the game page loads, the previously set game options are retrieved from local storage and used as parameters in the request to the database for a set of questions. Let's take a look at the code. The first useEffect hook has an empty dependency array, and so is only executed when the component is first mounted to the DOM. In this hook, the component retrieves the game options data from local storage to make a valid request for a set of questions. The second useEffect hook has an array of dependencies. This hook will run whenever any of the dependencies change, the prominent dependency being the questions variable, whose truthiness after the first execution of this hook prevents subsequent requests for questions being made. The questions are stored in local storage and passed as props to the conditionally rendered gameplay component. Back in the browser, we can indeed see that there is a set of questions stored in local storage. At this point, I'd like to demonstrate one of the reasons why we chose to persist data in local storage. If for some reason the user is unable to complete the current game session, they will be able to resume the game from where they left off. The gameplay component is responsible for managing the progress of the current game session and presenting questions to the user. There's quite a lot going on in this component and limited time to explain all of it, but let's have a look at the code. I'm going to slowly scroll through the file for you to look at. The key state variable is the question index, which keeps track of the question the user is currently on. All other state variables are essentially determined by the question index as the user progresses through the question set. As the user answers each question, their selected answer is added to an array in local storage. Please take a moment to observe how the state in local storage changes as the user answers each question. When the user has answered the last question, they click the Endgame button to navigate to the Endgame page to see their score. The Endgame page retrieves the user's selected answers from local storage and sends this data as a post request to the server, where it is compared to the correct answers in the database. Let's go and take a look at the code that handles this. Here in Query Score, we determine the user's score by checking their selected answers against the correct answers in the database. We structured the answers for each question as an array, where the first element always contains the correct answer. Here in the Endgame component, there is a useEffect hook that issues a request for the user's score, which is passed through props to the score component. I hope you've enjoyed this quick whistle-stop tour of our application's development and its inner workings so far. And now I'd like to hand over to my teammate Tom, who will be talking to you about how we might further develop the application in the future.
So what else would we do? We would first work on creating a working authentication system and ways of storing user data in the database. This would then open up the path to creating features such as peer-to-peer communication and interaction, including leaderboards, user dashboards, and user content creation channels, with the ability for users to give feedback on questions. We have also discussed adding the ability to rank questions in terms of difficulty based on how many users have answered them correctly and incorrectly. We could then apply this to the user's level of knowledge and present them with questions that match their desired difficulty level. Due to time constraints and the learning of new technologies, we did not implement test-driven development as extensively as we'd wished, and so we would introduce more tests as part of refactoring. We would also like to investigate and introduce TypeScript into the project to make the application more type-safe and to help catch bugs as the application grows.
So, there's lots to work on and improve in the future of our app. Tom, Michael and I have all enjoyed the course and completing the final project. A big thank you to all the tutors who have been a massive help throughout and the whole cohort who've been great to work with. Thank you for listening.